So today we're going to look at adding and subtracting rational expressions. Can anybody state in their own words, what is a rational expression? What's another way to say a rational expression? Like these are rational expressions. Example 2 is a rational expression. Remember, how could you say it in easier words? What is a rational expression? Yeah. Okay, you're going a little bit advanced on today's. You're right. We want to get common denominators. That's certainly. But I'm asking you before today. What is a rational expression? Like, what is it? So if I want to add and subtract them, I need to know what they are. Okay, they're fractions that have variables in them. Okay, a rational expression. So let's maybe write ourselves a note. Okay, a rational expression is a fraction with variables. And technically, they're fractions that have polynomials in them. So not just variables, but they do have to be polynomials, like x squared, x cubed. We can't have fractional exponents or square roots. Okay, so when I'm talking about adding and subtracting rational expressions, I need you to know what they are in order for us to add them. So we're going to start off with some real basics here. If you look at example 1, 7 over 16 plus 8 over 16, all you do is add the numerators and you keep the common denominator. If you could reduce the fraction, we would reduce the fraction. In letter B, 5 over 9 minus 1 over 9 is 4 over 9. The same principles apply when adding or subtracting rational expressions containing variables. So what you're going to do is you make sure they have a common denominator. So we're going to start off with common denominators, then learn how to build common denominators. So step 1, add or subtract the numerators. Place the sum or difference of the numerators found in step 1 over the common denominator. Step 3, simplify, and that's a typo, should say fraction if possible. So then you're going to see a beautiful connection to what we did yesterday. Remember all the marker board problems we did, and we simplified. And so what we're going to do is we're going to try to see if we can simplify. So in example 2, all I'm going to do is add the numerators and put it over the common denominator. That would give me x plus 8 over x minus 5. Can I cancel the x's? No, okay, it should be an emphatic no. I can only cancel common factors, not terms. All right, example 3. I have a common denominator, so now I'm going to add the numerators. And what's really cool is I have created a problem like what we did in the previous section. We simplified. Can I factor the numerator? Yes, okay, I see a lot of good head shakes there. X squared plus 7x plus 10. Can you think of two numbers, Grace, that multiply to 10 and add up to 7? 5 and 2. And make sure you are checking your work when you factor. Okay? Check it. X times x is x squared. The outer, 2x plus 5x is 7x. 5 times 2 is 10. Do not proceed until you've checked your factors. Now, guess what? I have x plus 5 over x plus 5. And that leaves me with x plus 2 over x minus 2. Now let's pause here a moment, and I want to refresh your memory from yesterday. Let's put this in our notes. Recall, A minus B over B minus A is -1. And maybe put a bubble around it. Okay, put this in your notes. And you guys, I had a couple of students come into office hours today, and I was so pleased because the students had their notes, they were looking at their notes, they can still ask questions, but you want to be using your notes. You guys, I'm giving you beautiful steps here. So before you ask for help, look at those notes. And remember, we talked right before break about digging in and really trying harder on your own before you ask for help. So let me ask you this. X plus 2 over x minus 2, does that cancel to -1? No, it's not A minus B over B minus A. That one doesn't cancel. All right. When subtracting rational expressions, note, and I want you guys to put an underline here, note that the entire numerator of the second fraction must be subtracted. Please underline this. This is super, super important. Also, note that the sign of each term of the numerator being subtracted will change when the parentheses are removed. So here's what I mean. I have a common denominator, and so watch what's going to happen. I'm going to subtract, and I'm going to put an extra step this time, and then we'll see if we can't skip it in the future. So go ahead and write this down in your notes. When you are subtracting, you've got to remember to distribute that minus sign. So watch what's going to happen. This is going to give me x squared minus 2x plus 3 minus x squared plus 4x plus 5. Notice I have flipped every sign in that parenthesis when I remove the parenthesis. And that's what that note means. Now let's combine like terms. I'm going to draw an arrow and continue it over here. So let's combine like terms. X squared minus x squared cancels. Negative 2x plus 4x is 2x. 3 plus 5 is 8. All right, so this is exciting. This is just what we did yesterday. What do we do when we want to simplify? Factor. And then you're right, Kat, the first step in factoring is find a GCF. So let me give you a head start. Factor your numerator, factor your denominator. Yes. You don't have to do the split the middle if you can handle it. All right, so I have a GCF up in the top, x plus 4, 2 times x plus 4. That's x plus 4 times x plus 3. X plus 4 cancels, and I get 2 over x plus 3. Now, something I didn't talk about yet, and what we can do it here, is when you get your denominator factored. Do you remember yesterday how we talked about restrictions? It's of your factored denominator. So my restrictions, even though the x plus 4 canceled, x still can't be -4 or -3. Let's go back up to example 3. X can't be -5 or 2. And in example 2, x can't be 5. Yes, and the reason why it's the opposite is, do you remember, if you set x minus 5 equal to 0, you do the opposite. Yeah. So you're right, there's a little pattern there with your restrictions. All right, so that was the easy part. That was if you have a common denominator, you add and subtract numerators. When you get down to the bottom, step 3 is simplify the fraction if possible. All right, so when you're ready, let's flip it over. and I'm going to go over how you find a common denominator. When you add or subtract fractions, you begin by finding a common denominator. This is what you must do when you add or subtract rational expressions. We seek the least common denominator, the LCD, because it produces the easiest calculations. You can add or subtract rational expressions only when you have a common denominator. Here, the least common denominator, or LCD, of a collection of denominators is the smallest expression that is divisible by each of the given denominators. This is equivalent to saying the LCD is the LCM. So, in the box, and I want you to make sure you use these notes, it'll really, really help. Step 1, factor each denominator completely. Any factors that occur more than once should be expressed as powers. For example, if you have x minus 3 times x minus 3, take an extra step, rewrite it as x minus 3 squared. Then you list all the different factors that appear in any of the denominators. When the same factor appears in more than one denominator, write the factor with the highest power. If you have x and x, you just put x. If you have x plus 2, you put x plus 2. But if one of them's x plus 2 and the other one's x plus 2 cubed, you're going to put x plus 2 cubed. All right? And this will make a little bit more sense. Then you just put the LCD as the product of all of those factors. So watch this. In example 1, the LCD, I have a 5 and a y. So the LCD is 5y. So now I'm going to take us an extra step and then we're going to add here, okay? So watch what you're going to do. My LCD is 5y. So I'm going to multiply by the missing factor. The missing factor is y. So here's a beautiful connection to Algebra 1. Do you remember the multiplication property of 1? And we talked about this earlier this year. We said, gosh, that seems really silly to say a times 1 is a. 5 times 1 is 5. Like, no duh. We know that. But here's the cool part. Now I'm multiplying by 1, but it's in disguise. Okay? It's in disguise here. So now I'm going to take 1 over y, and what do I need to multiply by that's going to build the common denominator? 5. Exactly. And we're going to make it 5 over 5. So what we're doing when you don't have a common denominator, you're going to figure out the common denominator, build it, and they will come. So this is going to go y over 5y plus 5 over 5y. Then I can add. And I'll tell you, one of the most common mistakes I see that students do, and I'm trying to prevent you from doing it, I'll have students who cancel the y's and the 5's, and then they're back to the start, and you can't add them, okay? So yes, it's true, I can cancel those, but if you do, you're stuck. So we're building it, so now this is y plus 5 over 5y. Can I cancel the y's or the 5's? No, absolutely not, we cannot. They have to be factors in order to be able to cancel. Sums and differences separate terms. We can't cancel terms. Let's talk about restrictions. You set the LCD equal to 0, and that's your restriction, so y can't be 0. All right, let's do it again. In example 2, we're going to first find the LCD. So you list every factor, and if the factor appears on more than 1, you take the higher power. So I need a 7, but I have an x and an x squared. It's not x cubed. Yeah. It's just 7x squared. You have to take the higher one. Yeah. But you don't multiply x times x squared. All right, so here we go. Now we're going to build the common denominator. So Carter, if the LCD is 7x squared and I have x squared, what would I need to multiply by that gives me 7x squared?
7.
Yes, yeah, you got it. That's 7 over 7. All right. multiply by that's going to give me the LCD of 7x squared? I don't have any y here.
Or x over 7x.
Okay, I'm at 3 over 7x, and I want to know what do I have to multiply 7x by that gives me 7x squared?
Oh, x.
Just x, right? Okay, there's no y's here. So here we go. I just need to multiply then. I need to multiply by 1. That's my multiplication property of 1. So this is 14 over 7x squared minus 3x over 7x squared. Yay, I got the common denominator. So it's 14 minus 3x. And I did not do my restrictions, so let's come back over here. You take 7x squared, set it equal to 0. Divide by 7, square root, x can't be 0. Yes. You
14, you did that, and then you got
Yes.
that.
Yes. So you've got to build the common denominator with the first one. You build the common denominator with the second one. So they're not necessarily the same. It's like what's missing to give you the LCD. Okay, let's try the next one. Example 4. We're going to find the LCD, then we're going to subtract. So, anybody feel like they're really getting this? Jacob, you want to try it?
You skipped number 3.
Oh, okay.
There's no number 3.
There's no 3, right?
There's no
No, I know the three.
Oh, yours is a 3. And mine's a 4.
It's 1 over 18x cubed.
Oh, the,
Yeah, ours-
wait, the equation's,
Oh. Let's skip that one then. Let's just go to the 4. Yeah, sorry.
I was making hard one.
Yeah, sorry. No, we'll skip that one. Let's go. Just go to 4. All right. Sorry, Jacob. Then you're like, what? You were so ready for that one. Okay. So if I have an x and an x plus 3, so I take each unique factor. It's x and x plus 3. You actually need both. Because the x is an x to the first. X plus 3 is a quantity, so it's a unique factor.
You factor it in, like, distribute it to x squared plus 3x.
You don't want to do that, just because now what I'm going to do, see, I want it factored, because what's missing is an x plus 3.
Okay.
Do you see that? Like, it's a little bit easier to see what you need. You guys, Grace asked a really good question. She asked if we should distribute the LCD and make it x squared plus 3x. And the answer is no. That's a good question. It's a little bit easier to build the LCD if they're factored. Okay, so what do we need to multiply the second fraction by? X. Nice. Okay. All right, here we go. So that's going to give me 5 times, or wait a minute. I don't want to erase x. It erases my whole thing. Okay. So I'll just write it again. Minus, now that's 7xy, right? Okay, 7y times x is 7xy. Anytime, if you feel that I'm going too quickly for you, you can always watch the video again. You can also look back at the notes before you start homework and try to self-talk and say, okay, what did we do? Why did she do that? You know, because I know that sometimes I can get going a little bit too fast for you. So now I'm ready to put this over the common denominator. So I get 5x plus 15 minus, it does not matter the order there. All right, and there's nothing else I can do with that numerator. Let's go back. I forgot the restriction again. So x can't be 0 and x can't be negative 3. Huh, I must not have changed yours. I don't know why you guys had it at 1. All right, what's on your next page then?
Example 5.
Wait, that is so not what I have. Holy cow. Okay, yeah, this is, all right, we're gonna have to jump around. I do not know what I did here. All right. Do you guys have this one somewhere?
Yeah, very well.
Okay, go there, go to this one. The total process of adding or subtracting rational expressions uses finding the LCD and writing equivalent fractions. So, I want you to add a step 0 here. Make a step 0, factor each denominator. Yeah, so I guess just follow my screen here and you might have to jump around. Step 0, factor each denominator. Step 1, determine the LCD. Step 2, rewrite each fraction as an equivalent fraction with the LCD. Then you add or subtract, and then simplify if possible. So find this example. 7 over x plus 3 over y. So there's no factoring, they're ready to go. So anybody want to try this? What's the LCD? XY, you got it. XY. Let's do the restriction right here. X can't be 0, y can't be 0. So I need to now build the common denominator. So I'm missing a y from the first one. So I'm going to multiply by y over y. The second fraction is missing the x. So I'm going to multiply by x over x. Now, do you notice that my second denominator looks like yx? But the commutative property that you learned in Algebra 1 allows me to switch the order. So I'm going to put it over the common denominator, xy. That's 7y plus 3x over xy. I cannot cancel because my numerator contains 2 terms. Cannot cancel terms. I know. All right, so jump to this one. That is super weird. I don't know how I did this. What I did there. Okay. All right, so jump to this example 3. It says subtract x over x plus 5 minus 2 over x minus 3. All right, what do you think the LCD is, Daria? Okay, those are my restrictions. X can't be negative 5 or 3. You got my restrictions. But what's the LCD? Yeah, x plus 5 times x minus 3. Because they're unique factors. Okay, x plus 5 is a factor. X minus 3 is a factor. So I'm going to need to build the common denominators. So the first fraction, I need to multiply by x minus 3 over x minus 3. The second fraction, I'm missing the x plus 5. All right, so this is x times x minus 3 over the common denominator. I take 2 times x plus 5, and I'm just going to switch the order using the commutative property. All right, now I'm ready. I'm ready to take care of the numerators. That's going to give me x squared minus 3x. Now be super careful. This is minus 2x minus 10. Why is it minus 10 when that's a plus 5? It's a minus the 2 times the 5. So be careful. And I had you underline it in your notes, okay? When you're subtracting, you've got to be careful to distribute that minus sign. All right, I'm going to continue it over here. So I get x squared minus 5x minus 10. Now you want to do what I like to call forward mental thinking. In your forward mental thinking, before you start writing, I want you to think, can you think of two numbers that multiply to negative 10 but add to negative 5? Well, you've got 1 and 10, 2 and 5. Is there any way 1 and 10 can add up to a negative 5? Is there any way 2 and 5 can add up to negative 5? No. So you stop. Okay, you stop here. That's as far as it goes. All right, that's as far as I wanted to get with this. What I'd like you to do now is go grab a marker board. And we're going to do just some practice here.